social being. The army grooms you into a well-rounded individual. A leader, a decision maker. But that's not all. It teaches your children, lets you grow, learn, and discover. It gives you the opportunity to serve abroad as part of the UN peacekeeping force. The army looks after your family and you. Even after you retire. It prepares you for a second career, should you choose to pursue one. Look no further. This is India's most exciting workplace, where your country is your workstation, where the world is your office, where your quality of life has no comparison, where respect matters much more than designations. Here, sacrifices are remembered. The value of life revered. And heroes never forgotten. Your existence takes on more dimensions than you believe your shoulders can carry. Here is where you become the best you can be. This is your life. A life you never imagined. A life you can only dream of. Come, join India's most exciting workplace. The Indian Army. Live a life less ordinary.
That echoes their sentiments and something that they live with every single minute of their life. So I want you all to repeat after me straight out of your lungs. Jai Hind! Jai Hind! Jai Hind! Beautiful. Thank you. On that note, let us all please rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जनगण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे।
Thank you. Please be seated. It's time for us to take the event forward, and we cannot have a better start than again requesting Ms. Ranjana, the Managing Director of Accenture, to please come up on stage, along with Mr. Nitin Sawant, the Director Accenture, to give us the keynote address for Big Data Analytics. A huge round of applause for them, please. Thank you.
Good morning, everybody. I think we had a lot of inspiring speeches before this session, and I think Honorary Vice Chancellor also mentioned about the value of big data and the future of big data industry for IT professionals and for all of us here. I think on that key message from Honorary Vice Chancellor, let me begin our keynote. Right. So when we say big data, I just wanted to explain to you what do we mean by big data, right? How big is big data, right? So some common examples that we know are probably we have our 16 GB, 32 GB phones, right? That's something which we understand. And GB is something which we all have got used to. We have 16 GB, 32 GB RAMs. We have, I think the maximum that I have heard is 1 terabyte of hard disk. So we also understand terabyte, right? Is that big enough? Maybe for us it is big enough, right? But we are talking about really testing our exponential algebra knowledge here, right? We'll see what it means to say 10 to the power 25, 35, 45. And in this process, you will also learn algebra as you learn big data, right? So we'll talk about how big data is. We'll also talk about why the need for big data now suddenly, right? What has happened in the last few years for us to really look at big data. Why big data is a solution for this humongous data that is being created all around us. To give you an example, there is 1.7 megabyte of data created every second per person on this planet. Right? As some of you are listening to me, some of you are still texting, right? So you are creating that data as we go through the next 2 days, right? We will, if we go to the next slide, right? So let me first focus on why big data, right? we can go ahead. Yeah. So why big data? Primarily because, and again, let me give you some examples that we understand, right? How many of you have heard of Teradata? Right, lots of you. And we all know that probably the maximum data that you can store in a Teradata machine is around, say, 20 terabytes, give or take plus or minus 5 terabytes. And you also know how much license money you have to pay to Teradata. I hope there is nobody from Teradata here, but for every megabyte, gigabyte of data that you add to the machine, in analytics report, which then is used for forecasting on a quarterly basis, yearly basis for the next 10 years. So that is how we understood data, right? Many of the white hair and probably gray hair out here, that's what we know about data and then that's the max that we really operated on. But in the last probably 10 years or so, there is a huge deluge of unstructured data, right? All the data that we had, we used to create relational databases, create tables, lots of software engineering principles to design the database, and suddenly there came a Google, a Facebook, a Twitter, right? And all the data structuring went haywire, right? So the volume was compounded with the whole velocity of the data as well as the variety of data, right? So 3 V's, which are supposed to be the characteristics of big data: volume, velocity, and variety, right? And people also have 4 V's, 5 V's, many of those, right? Veracity and all of that. But I think the 3 V's stay common in most discussions, and that has really contributed to the huge deluge of data that we now, as corporations, as governments, need to really analyze, to predict, right? Single dashboards, yes, great that we want to forecast maybe the next quarter, but people now want to forecast the future, right? Use artificial intelligence, use cognitive sciences, do machine learning, run robots, right? Understand what devices are telling us. So I was talking to Mr. Mane just before the session. So he was talking to me about smart meters, where you can turn on and off maybe these lights as well remotely from your phones. But those devices are spewing data day in, day out in millions of terabytes, as we spoke of. So all of this unstructured data, which is getting added to the structured data that organizations, governments, huge firms had, is really complicating the whole analytics problem that people are trying to solve. Right? How do I know when the next hack attack will happen? How do I know, with so many millions of bank customers, who is going to do the next fraud? Right? With so many smart meters throwing a lot of power utilization data, where is the next grid breakdown going to happen? So many problems. Our Aadhaar program, right? That's a huge example of big data, right? So much, is it 1.3 billion or 4 billion now? As we speak, it's growing, right? So this huge population of India, all our data, and it's, as you can say, it's unstructured. It's got your demographic, your personal details, but it's also got your photographs, it got your thumbprint, your eye scan. So multiple types of data going in there and really adding to the whole analysis problem, right? So it is an analytics problem that people could not and have not been able to solve using our traditional methods, and that's where I think big data is the solution and the key, right? So I think we really understand why big data. As I said, data is exponentially growing. Right now, as we speak, it is predicted that by 2020, we'll have almost 44 exabytes of data, right? And I don't know how 10 raised to how much is that, but I think very learned professors here. I'm in the university, so I'm sure everybody knows the power to which it is exabyte corresponds to. But I think that's the volume of data, and it's really increasing. So that point being made, there are huge use cases out there in the industry, and data is, as I said, getting created as we speak. And to analyze that, we need really new methods for really solving these problems that we are facing. Right. If we go next. Right. So traditional methods. What did we do? We had structured data. Now we have really unstructured data. The storage costs really for this kind of data will be huge, humongous. So we have to find some non-conventional methods to store that data, and also process that data. So the Teradata example that I gave, we brought all the data that we had to one server or one machine, and then we applied the functions to that data at one single physical space. But the big data, it's a completely different paradigm. We take the functions to the data. So your data resides, and that's how, and then a very famous example of Google, where they have really very inexpensive commodity machines running in clusters, and the functions of search that we do, right, goes and runs those functions on those data, on that